This is my video for the semester 2 final, and I just took all of these learning targets and then crossed out the ones he crossed out and then did most of them in this 9-page document. Some of them I felt like were repeats, so I just didn't do them again, but otherwise this should cover most of it. Yeah, so first we started with chapter 5 where we did composite functions. Basically, just when you're given a value, so for this example, we have the value of 1. You just plug that value into the first function, so in this case, g of x. So we're plugging 1 here, and we'll get 4. And then we're going to plug 4 into that f of x function, solve that, and get 29. And then if you want to, I have, I think 3 examples kind of for questions to practice. It's here, and then I can show the answer now. Okay, and then the next one is I can form a composite function. So this is for when you don't have a value, so it's just x. You just plug in the entire function. So for this one, you would plug in this whole g of x into each x of the f of x function, which is what I did in green. And then I just squared this and then distributed the 3 and then simplified all of this into this equation. And then I have an example using these same functions, and I'll put the answer up. Okay, the next one was restrictions of domains, and specifically for domains of a composite function. So if you have a composite function, I'll just work through this example here. The first thing you do is figure out what the domain of each function separately is. So in this case, f of x, x can't be -2, and g of x, x can't be 1. The first thing you do is just start with the domain of what the first function can't do. So g of x can't be 1, so that's what I started with here. And then you have to think about what the second function can't equal. So this f of x can't equal -2, but the only way you'd get a -2 here is if this whole equation equaled. And that's why over here I have 4 over x minus 1 equals -2. Simplify that and you get x equals -1. And that goes into the domain. Because if x equaled -1, if x equaled -1, it would plug into this equation. And this equation would equal -2, which we know doesn't work for this one. So if you want to do an example, here it is, and then I'll put up the answer. Okay, the next thing was one-to-one functions. So basically just no repeated outputs, and you just do the horizontal line test. So all of those only have one output. It only hits one line. And then if you just get given a set of ordered pairs, then you have to make sure that there's no repeated y values. So in this case, the 4 is repeated, but in this case, none of them are repeated. The next thing was finding inverses. So basically, anytime you have to find it, you just swap x and y. If you're given an equation, you swap x and y, but then you have to isolate to find y, like in this example. So remember, f of x is also the same thing as y. So then I just swap all the x and y values, and then I isolated down to get y. And then if you're given a graph, for example, you'd have point 2, 1. So instead you'd graph 1, 2 here. You have -1, 0, so you'd graph 0, -1. And then you have -2, -1, so you'd graph -1, -2. All of your inverse graphs will follow this line of y equals x. It'll flip across. That's what those purple lines are. And then the next thing was the domain and range of an inverse. So if you can find the domain of a function, then you found the range of its inverse, and vice versa. If you have the range of a function, you can find the domain of its inverse. And then the next target was just knowing how to graph all of these parent functions. So I literally just imported my notes from that section. I think the ones it's missing are exponentials and logarithms, but I didn't feel like adding it. So basically just know the like general shape of these functions. And then next one was solving exponential and logarithmic equations or converting back. So like Ms. Tribal said, b is the base, and then log solve for the exponent. So just be able to convert back and forth between those. Okay, the last thing for chapter 5 was properties of logs. So basically, if you have a log with two things multiplied, you can split it up into two things added. Kind of similar for quotient. If you have two things divided, you can split it up into two things being subtracted, two logs being subtracted. And then for power property, you can drop an exponent down to the front. So that's what this R is. And lastly, the change base formula. Just remember that you can do, like, for example, if this was log 6 of 8, and you don't know how to put that into your calculator, you could just do it as log 8 over log 6. And remember that is common log. You could also technically do it as natural log 8 over natural log 6. Whatever you feel like. Okay, next chapter, chapter 2. The first target was whether something was a function or not. It just means if there's one output for each input, and you just test by doing the vertical line test. And the next one was the value of a function, so all you have to do is plug in x, or you can have like a y value of a certain x value, if that makes sense. So like if they're saying like what does f of x equals 1, I guess. No. Equals 1. You would know that, well, when is y equal 1? And in this case, it's when x equals 2. So your answer would be x equals 2. The next thing is the domain of a function, which I kind of went over, but just basic standards. Your denominator can't equal 0, and then anything under a square root has to be greater than or equal to 0. You can't take the square root of a negative number, but you can take the square root of 0 because it just equals 0. The next thing was sum difference products and quotients of two functions, and I mean, you just put the two functions in and you simplify it into one complete function. And then next was domain range, maximums, minimums, intervals, and intercepts of graphs, which I didn't really know how to explain it because I felt like you should just know it. It might just be me, but basically domain is what your x values can't be, range is what your y values can't be, maxes and minimums, intervals if they're increasing, decreasing, or constant, so increasing, decreasing, or just staying the same. And then intercepts, just know your y-intercepts are when your x-intercepts are when y equals 0, and your y-intercepts are when x equals 0. Next was finding even and odd functions. So basically what you do is you take the function you're given, and you're going to make all your x values negative. If those spit out the same answer, it's even. The way I think about it is if this negative doesn't even matter, it's an even function. But if it spits out something different, you're going to take you're going to make the whole functions negative and see if that equals what you had previously gotten. If that doesn't spit out the same answer, the answer is neither. So I did an example, 2 of them. So there's just this function, and I made all of the x's negative. So this x and this x became negative. Negative x to the fourth will end up being positive, and negative x to the second will also be positive. So it spits out the same as this, which makes the whole function even. Over here, I first made all of these x's negative, which spit out this function, this is not the same as this function. So I went on and I did the negative function of it. And when I did that, it spit out this, which is the same as this, making the whole thing odd. The next thing is make sure you know how to do zeros, maxes, minimums on your calculator. And then piecewise functions and limits. So basically I just took this graph from the review, and so what I did is for now is I just copy and pasted all of the things, and I was just going to explain why. So is f of x a function? Yes, because it passes the vertical line test. The domain is negative infinity to infinity because it will hit every x value. It's not continuous though because of this break. You can't draw this without lifting up your pencil. The range is from negative infinity all the way up to 6 with a bracket because it touches. And then to find f of negative 2, you just find when your x value is negative 2 and the y is your answer. So right here, y equals 0, your answer is 0. Next was limits, which are just trying to explain when your graph approaches a certain x value. So in this problem, when x equals 4, on both directions, the graph is approaching 6. For negative 2, coming from the right, because of that plus sign, your graph is approaching 0. But from negative 2 coming from the left, your graph is approaching negative 3. If you just had something that said limit x negative 2, your answer would be does not exist because from different directions, the limit is different. And then the last thing was mathematical models, which I don't understand, so just go to those notes. Moving on to chapter 3, the first target was for your axis of symmetry and the vertex in standard form and in vertex form. So I just did, this is just like an example, but I think it makes more sense when I do it all. Or wait, like I'm going to do an example. These are just like the basic like formulas for it. So basically if you're given standard form, you use the formula negative b over 2a. In this case, b is negative 6 and a is 1. So I just plug those in, negative 6 and 1. Solve, get 3. Your axis of symmetry is a line, so you need x equals 3. If you want to find the vertex, you're going to take that axis of symmetry line, you're going to plug in 3, and you're going to plug in 3 for your entire thing. So I put a 3 here and a 3 here, solved, got 0. Vertex is 3, 0. In vertex form, it's a lot easier. Your axis of symmetry is just your h value. So in this case, it's negative 2. Remember, this is x minus h, meaning the h value is negative. And then the vertex is you're going to take that same h value and you're going to plug in your k value, negative 3. So that's why your vertex is negative 2, negative 3. Next was completing the square. So I just have 2 examples. This one, there is no coefficient in front. So what you do is you just write x squared plus 12x. You divide this term by 2. You get, in this case, I got 6. Then you square it, got 36. So I add 36. But you can't just add 36 without subtracting it because then your entire equation would be completely different. And once you have it in this form, you're able to write it as x plus half of this term, so 6, all of that squared, and then minus 26 from up over here. If there's a coefficient in front, factor it out, so factor out the 2, and then same thing, factor out the 2, and then here you're going to take half of it, which is 3 square, so you're going to add 9. Since I added 9, I have to subtract 9. But you have to remember that this 2 will get distributed, so you actually have to subtract 18. And from there, you keep the 2, do half of this number, which is 3, and then simplify that to get your final answer. Quadratic inequalities. I have this really simple one where it's just like basic algebra where I factored out the negative 3, and then I divided by negative 3, which is why this sign flips. And then, yeah, you just simplify it because you would add 3 and then divide by 2. So that's your final answer. Over here, I factored out the quadratic, so I get x plus 7 and x minus 3, meaning negative 7 and 3 are the zeros. And then I realized that x squared is a positive coefficient in an even exponent, which means the end behavior is like this. And since these are positive and these are multiplicity 1, which means they have to cross, this will cross here and cross here, meaning positive, negative, positive. Since we're asking when it's less than 0, we're looking at all of the negatives. So from negative 7 to 3, and it's parentheses because it does not include when it's equal to 0. Moving on to the last chapter, chapter 4, there was a target that was just rational versus polynomial. Rational, basically, if you see it written as a fraction, and the polynomials, the rest of them. So x minus 1 over x plus 2 squared, that's rational. But continuous or polynomial would be x squared plus 3x minus 4. That'd be a polynomial. Like I just explained up here, end behaviors and multiplicity. So I'm just going to kind of break it down to how I remember. If it's an even degree and a positive leading coefficient, I just think of the equation x squared, which would be a parabola like this. Both the left and the right go up. If I have that same even degree, but it's negative, I think of this parabola. So both the left and right go down. However, if it's an odd degree, I think that these end behaviors don't match. They do something different. But they always go the way it ended. Let me explain that. This is positive, so it's going to end positive. This is negative, so it's going to end negative. And then for multiplicities, if that's a multiplicity of 1, so just like x plus 1 or x plus 3, those will have a multiplicity of 1, which means it will just cross through the x-axis. If it's even, so x plus 4, it's squared, or it's to the 4th, those are when it's going to bounce or touch and turn, which is like this. Like, where it just touches and turns right back down. And then lastly, for odd ones, these are inflections. So instead of just crossing like 1, it's going to cross, but it's going to kind of inflect like that. And then last page, asymptotes and wholes. So you're going to look at your bottom. You want to make sure it's completely factored out. And then any time it wholly cancels out, it cancels on the top and on the bottom, you have a whole. And if not, you have a vertical asymptote. So in this case, vertical asymptote at x equals 3 and a whole at negative 2, because that would make the bottom equal 0. And then you just plug in negative 2 for the rest of it. So since these cancel, you just plug in negative 2 here, and then you get 1 over negative 5. For horizontal asymptotes, if the numerator's degree is less than the denominator's degree, you get an asymptote of y equals 0. If they're equal, you're going to get y equals a over b, which means like if your equation is x plus 2, no, let me do 3x squared plus 1 over 2x squared minus 4, your asymptote would be at y equals 3 over 2. If the numerator's degree is more than the denominator's by exactly 1 degree, so if the degree is 3 and then the denominator's degree is 2, this would work. This is when you would do synthetic division, and your answer would be oblique or diagonal. And then lastly, if the numerator's degree is more than the denominator's by more than 1, so if it's 4 over 2, the degrees, then there's no horizontal asymptote or oblique asymptote. Okay, the last section is polynomial and rational inequalities. So we're going to start with this one. You know the zeros are at negative 3 and at 1. And then what you would do is you would test a number that's less than negative 3, a number in between negative 3 and 1, and then a number that's greater than 1. In this case, it turns out to be negative, positive, positive. And then you would just write your answer for all of the numbers that are greater than 0. So all of this but not including 1. Because not when it equals 0, when it's greater than 0. So your final answer would look like this. I'm pretty sure. Could be wrong. Next would just be a rational one, where this is your original equation, and then I factored out the bottom. That means you're going to have a vertical asymptote at negative 2, and then also at 2. And then you're going to have a 0 at 1. Okay, and then in this case, you would test points again, and it becomes negative, positive, negative, positive. In that order, you would just test them. And then you're trying to find everything that's greater than or equal to 0, which would be from here to here, and then here to here. Since this is a vertical asymptote, we can't include negative 2. So we would get, these are open circles. You'd get negative 2, comma 1, and then 2, comma infinity. And, okay, well, that was my final review for the semester 2 final, and I hope it was helpful. And if you have any questions, just, text me, DM me, let me know, because I like helping with math more than I like helping with other subjects.